Now, when we determine vertical asymptotes, saying that they are vertical asymptotes is not good enough. Not enough. We also have to find the limits. You thought that we put the limits aside and they will never follow us. They will follow us, and they are following us now. So x minus 1, x plus 1. So when we plug in 0, the denominator is 0 and the numerator is 3. Do you remember what we said for such a case? When we have a number divided by 0, what did we call this case? And what are the options for a number divided by 0? 0 over 0 has hope. Infinity over infinity has hope. No guarantee, but it has hope. What did we say about this one?
No.
Absolutely no hope. There is no hope for this. For no hope, there are 3 possible answers. Can anyone refresh our memory? What are those 3 for no hope?
Is it 0?
And the last possibility? What was the third case here? The third possibility?
Undefined.
Yes, meaning DNE. Yes. So I know that since it's 3 over 0, I have to have one answer. Which is the answer? Well, I have to determine from the left and from the right. From the left, imagine negative 0.2. Negative, negative, but positive. And of course, this is 3. Don't even worry about the numerator. The numerator is 3. With negative 0.2 from the left of 0, this is negative, this is negative, this is positive. Which of these 3 will I write here? What do you think? Positive at the top, what is the sign in the denominator? Two negatives and
Negative infinity.
2 negatives and the positive. Careful. 2 negatives and the positive will give us what sign?
Positive.
Yes. So then this over this, which one do I pick?
Infinity.
Yes. Because it's positive over positive. Excellent. What does this mean? It means that if this is x equals 0 as the vertical asymptote, from the left-hand side, the function goes to infinity. So we will be able to determine all of those. So we will have to find those limits. Okay. Now let's look at an example with horizontal asymptotes. Although we can determine the horizontal asymptote for this one. So let's determine the horizontal asymptote for this one. So f of x equals x plus 3 over x cubed minus x. So understand one thing. Vertical asymptotes come from the values where the function is undefined unless the factor disappears. Now, horizontal asymptotes are determined by simplifying the limit as x approaches infinity and the limit as x approaches negative infinity from x plus 3 over x cubed minus x and x plus 3 over x cubed minus x. So horizontal asymptotes are determined by simply finding the limits. Vertical asymptotes, we determine them where the function is undefined unless the factor disappears. So that's why we did this a long time ago. What is the degree of the numerator? Can anyone give us a degree of the numerator? X plus 3, degree?
First.
1, right? Perfect. For the denominator, degree?
Three.
Perfect, awesome. So now I'm asking you this. At infinity, this is the key. At infinity, small degree over big degree, what will the answer be? And again, this is at infinity or negative infinity. Small over huge. I have a pie, and I want to share it with everyone in Maryland. When I get to your door, how much is left? I have one pie for several million people.
0.
Exactly. Exactly. Small divided by big when x approaches infinity or negative infinity. No other number. This is a symbol. Okay. So that means that y equals 0 is the horizontal asymptote of this function. Okay? And we'll look at other examples. I just would like to, if we have time, we have 10 minutes, I'd like to graph a rational function. Sketch the graph, blah, blah, blah. So we're going to start with something very simple. Let's start with 35. 35, f of x equals negative 2 over x minus 5. Can anyone give us the domain of this function? What x cannot be? X cannot be. Can anyone tell us what x cannot? Yes, x cannot be 5. Careful what I do with that. Means that I cannot put anything in here. If the function is undefined, of course the first derivative will be undefined. Of course the second derivative will be undefined. There is nothing. Can I simplify x minus 5 from the denominator with the factor of x minus 5 from the numerator? Do I have a factor of x minus 5 at the top? Can I simplify? Is there a factor of x minus 5 at the top? I know it's a silly question. Do you see an x minus 5 at the top?
No.
No, which means x equals 5 is a vertical asymptote. I cannot simplify it, which means x equals 5 is a vertical asymptote. I have to find the limits left and right immediately. So the limit of negative 2 over x minus 5 when x approaches 5 from the left, and when x approaches 5 from the right. Of course, they are negative 2 over 0, both of them. So this is trouble. There is no hope. They have to be infinities, but I don't know which one. So 5 from the left is 4.9. Can you plug in 4.9 here and just tell me the answer? Keeping in mind the numerator is negative 2. with 4.9, is the denominator positive or negative? 4.9 minus 5. Is the answer positive or negative? (4.9 minus 5), positive or negative? Anyone, please? Everyone knows 4.9 minus 5. Positive or negative?
Negative.
Negative. Perfect. So I have a negative of a negative. So what do I write as the answer? I have negative over negative. The answer would be, when we divide two negatives?
Infinity.
Yes. Awesome. Now with 5.1, sign for 5.1 minus 5. What would be the sign of this when I plug in 5 from the right? 5.1 minus 5. The sign will be?
Positive.
Yes. What do I get with the negative at the top and the positive at the bottom?
Negative.
Indeed. Very good. Now I need these limits. In order to determine those limits, I have limit as x approaches negative infinity from negative 2 over x minus 5. And for x approaches infinity will be the same answer. Which of these two is bigger? Is the top bigger or the denominator that goes to infinity bigger? This is degree 0. Yes, the bottom is bigger. So then small over big when x approaches infinity or negative infinity, what will the answer always be? Small over big. Degree 0 over degree 1. Degree 1 over degree 3. I'm dividing negative 2 by infinite. What do I get? I divide degree 1 by degree 3. What do I get?
0.
Yes. I divide degree 0 by degree 1. I get 0. 0 and 0. I write myself a note, y equals 0, horizontal asymptote. I have to plug in 0 in the value, in the function. What do I get? Is negative 2 over negative 5, which is 2/5. There is no x-intercept because I cannot make the numerator 0. I finished with this. Now I move on to the first derivative. So f prime. Remember, I prefer this. You don't have to, but I think it's easier to differentiate this. I bring down negative 1 and I get 2. I copy x minus 5 to which power now? To which power? I brought negative 1 down and I have to subtract 1 from the power, times the inner function prime, which is 1. So this is 2 over x minus 5 squared. Positive, positive, always positive, and never 0. A fraction is 0 when the top is 0, but that's not possible. So this is always positive. Fine. Which means that the function is always increasing. I don't know. We'll see. What if I made an error? I will verify right now. From 0 to 2 divided by 5, which is 0.4. Yeah, yes, indeed. From 0.4 to infinity, yes, yes. From negative infinity to 0, yes, indeed. Finally, there are no points of max-min. The function is always increasing. In other words, the derivative is always positive. No change sign. no max min. So now when I want to find the second derivative, I get -4 x minus 5 to -3 times the inner function prime, so I get this. But careful, because power 3 can be positive or negative. So I have to be careful. So it's never 0 like the first derivative. So when I plug in a 0, this is negative, this is negative, so the whole thing here is positive. So this is the case. When I plug in 10 minus 5, this will be positive, but there is a negative there. That's it. Everything other than my table, everything else is gibberish. Means nothing anymore. When I graph a function with asymptotes, I have to graph the asymptotes first. 1, 2, 3, 4. They are not solid lines because they're not part of the graph. And this is an overkill, right? So it's y equals 0, and this is x equals 5. And now I'm told this. From 0 up to 0.4, from 0 up to 0.4, crossing the y-axis, going to infinity. Fine, no worries. From 0, increasing, crossing the y-axis, going to infinity. From opening up. From negative infinity, opening down, close to 0. From negative infinity, opening down, close to 0. This is y equals -2 over x minus 5. In many ways,